try to understand the meaning of sequencing problem. So what is sequencing problem? It involves the determination of an optimal order or optimal sequence of performing a series of jobs, okay, by a number of facilities so as to optimize the total time or optimize the total cost. Okay, here number of facilities means number of machines. Okay, so this is the meaning of sequencing problem. Now let us see the different types of sequencing problem. Types of job sequencing problem. Okay, here we have 5 different types of sequencing problem. The first one is processing n number of jobs through 2 machines. Okay, and the next one is processing n jobs through 3 machines. And the next one, processing 2 jobs through m machines. Okay, and the next one, processing n jobs through m machines. And the last one, processing n jobs through 1 machine. So these are the 5 different types of sequencing problem. So we are going to see numerical problem for each and every model separately. Okay, now we are going to see the numerical problem for the first one, that is processing n jobs through 2 machines. See the problem, processing n jobs through 2 machines. Okay, there are 9 jobs, each of which has to go through the machine A and B in the order AB. Processing times in hours are given as, here we have 9 jobs, okay, and here we have 2 machines, machine A and machine B, and these are the processing time. Okay, so each and every job has to process through machine A first and then machine B. So this is the order. Fine. Now with this information, they are asking you to find out, determine a sequence of these jobs that will minimize the total elapsed time. Also find idle time for machine A and machine B. Okay. Now we are going to see the solution for this problem. First we need to find out the optimal job sequence, then we will move to next step. Okay. Now look at the simple procedure for finding optimal job sequence. See the procedure to find optimal sequence. First we need to find the minimum duration among machine A and machine B. Okay. And if you find the minimum duration occurs in machine A, then we need to assign that particular job in the forward direction first and next like that for machine A. Okay. And if the minimum duration occurs in machine B, then we need to assign that particular job in the backward direction first, next like that for machine B. So forward direction is applicable only for machine A and backward direction is only applicable for machine B. Okay. See, the next procedure is in case of tie. See, there are 3 different situations are there for tie that we will see along with the problem for better understanding. Okay. Now look at the problem. See the problem. First we need to find out the minimum duration among machine A and machine B. So which one is minimum duration? This is the minimum duration. This occurs on machine B and 7th job. Okay. So this 7th job has to assign in the backward direction. The reason is the minimum duration occurs on machine B. So we need to assign this particular job in the backward direction first. Job number 7 you have to assign here in this order. Okay. After assigning job 7, again we need to find minimum duration among machine A and machine B. Okay. So here 3 is the minimum value, but it occurs in 2 different places on 2 different machines, machine A and machine B. Okay. So this is not tie. Why? Because it occurs in 2 different places for different jobs and different machines. So simply you can apply the procedure. What is the procedure? For machine A, forward direction. For machine B, backward direction. Okay. So here 3 occurs in machine A for job 2. Okay. So we can assign this particular job in the forward direction first. Job 2. Okay. The next 3 occurs in job 8, machine B. For machine B, backward direction, no. So assign here. Job 8. Okay. Now you can eliminate the two different jobs, 8 and 2. Again, we need to follow the same procedure to complete the optimal sequence. See, the next minimum value is 5, but it occurs in two different places but for same machine, that is machine A. So, this is called tie. So, there is a procedure in case of tie. Let us see the procedure. See the procedure for in case of tie. Okay, here the tie occurs in machine 1, that is machine A. Okay, for that, check the opposite minimum value of machine 2, that is machine B in our problem, and then assign the particular job first in the forward direction and then assign the next job. Okay, so this is the procedure in case of tie in machine 1. So we need to find out the minimum value in the opposite machine, that is machine 2. Now see the solution. See the problem. Here the minimum value is 5, no? Job 1 as well as job 9. Okay, so which job we have to assign first? That is our question, right? So for that we need to see the opposite value, opposite minimum value. The minimum value will be assigned in the first and the next job will be assigned in the next. Okay, so here the opposite value is 6 and here the opposite value is 7. Which one is minimum, 6 or 7? 6 is the minimum value. So you can assign job 1 first and then you can assign job 9 next. Okay, see one important note. In case of tie, even in the opposite minimum value, then select randomly. That is, we need to select the job randomly and assign them in the forward direction for mission A. Okay, now look at the problem. So this is the procedure in case of tie in the first mission. Okay, see, we have assigned job 1 and job 9. Okay, again we need to find out the minimum duration. So which is the minimum duration? 6 is the minimum duration, but here it occurs for same job for two different missions, mission A and mission B. Okay, this is also one kind of tie. Let's see the procedure. See the procedure. When the minimum value occurs in M1 and M2, that is mission A and mission B for the same job, it indicates that it will have alternative optimal sequence. Okay, so we will see this point along with the problem for better understanding. Now look at the problem. So here we have two alternative sequence, that is the first one is if we consider mission A, we have to assign this job in the forward direction. Okay, if we consider this 6, that is mission B, we need to assign job 5 in the backward direction. See, this kind of tie will have two alternative optimal sequence. Just copy the same sequence. Now we are going to decide that particular job whether to assign in the forward direction or backward direction. But for both optimal sequence, we are going to get the same answer. See the problem. For this particular job, that is job 5, if we consider mission A, we have to assign job 5 in the forward direction. Okay, job 5 will be assigned here. If we consider mission B, then we have to assign this particular job in the backward direction. So assign 5 here. So here we have two different alternative optimal sequence. Okay, see, after assigning job 5 in two alternative optimal sequence table, again you have to find out the minimum value. See here the minimum value is 10, but it occurs in three different places. For mission A, there is no tie because it occurs in only one particular job. Okay, so we can use the forward direction and we can assign job 6. Assign 6 in the forward direction for two different alternative solution. Okay, and for the next one, for mission B, there is a tie because here 10 occurs in two different jobs for the same mission. So this is called tie. What is the procedure for tie for the same mission? Look at the procedure for in case of tie on mission B, that is mission 2. See, if the mission B has same minimum value, then we need to check the opposite minimum value of mission 1. Okay, and then assign the particular job first in the backward direction and then assign the next job. Okay, see, important note, in case of tie, even in the opposite minimum value, then select randomly. That is, we need to select the job randomly and assign them in the backward direction for mission B. Okay, now look at the problem. What is the procedure for tie for the same mission? Select the opposite minimum value, okay, and assign the job in the backward direction, because the backward direction is applicable for mission B. So, which is the minimum value? Okay, job 3 is the minimum value, no? So, you can assign this particular job in the backward direction first. Okay, in the second option also. And then the next minimum value is 15. So, job 4 has to be assigned after 3. Okay, that's all. We have assigned all the jobs. So, we have found optimal sequence with the given information. Okay, now look at the problem. See the problem. Determine a sequence of these jobs that will minimize the total lapsed time and also find idle time for mission A and mission B. Okay, the first thing is they are asking us to find out optimum sequence in order to minimize the lapse time and to find out the idle time for mission A and mission B. Okay, now see the solution. See the optimal sequence. In this problem, we have got two alternative optimum sequence. Okay, anyway, we are going to get the same answer if you proceed with the first one or second one. I am going to take the first one for the further calculation. Let us see the calculation. See the next calculation. Computation of total elapsed time and idle time for mission A and mission B. Okay, and this is the job based on the optimum sequence, that is 2, 1, 9, 5, 6, 4, 3, 8, 7. Okay, and this is the information for mission A and mission B, that is in time, out time and duration. And the next one, in time, out time, duration. And the last one, idle time for mission B. Okay, first we need to write the duration for mission A and mission B based on the optimum sequence. Now look at the problem. See the problem. This is the duration for mission A and mission B for 9 different jobs. Now write the duration in the tabular column. Look at the solution. We have written duration for mission A and mission B from the given problem. Now we are going to find out in time and out time for mission A first, because there is no idle time for mission A during the process. Okay, so first one is job 2, the in time, this is the first job, no? So in time is 0. Okay, so how to find out out time? Starting time plus duration is equal to out time. Okay, so time in is 0, 0 plus 3, out time is 3. Okay, so after processing the job 2, then the mission A will take the second job. The next job is job 1. Okay, what is the in time? So after completion of the previous job, no? So after that, the mission will take up the next job. So in time for the next job is 3. The finishing time of the previous job. So 3 plus duration 5. 3 plus 5, out time is 8. Okay, and then mission A will take up the next job. So in time is 8. 8 plus 5, 13 is the out time. Then in time is 65 plus 11, 76. This is the way to find out in time and out time for mission A according to this sequence. Now let us see the calculation for mission B. Now we are going to find out in time and out time for mission B. Okay, so here mission A processed 9 different jobs continuously, but each and every job should process through mission A and mission B. Okay, this is the order. So look at the first job. Okay, so job 2 processed through mission A on 3rd hour. Now this is the in time for mission B for the first job. So in time is 3 plus duration 8. 3 plus 8 you will be getting 11 as out time for the first job. So job 2 has processed through mission A and mission B, and completed its process on 11th hour. Okay. Now look at the next job. Job 1. Its out time from mission A is 8th hour only. Okay. So this particular job will move on to mission B at 11th hour only. Why? Because mission B will complete the previous job on 11th hour. So after completing the previous job only, it will take up the next job. So mission B will take up the next job on 11th hour. So in time for the next job is 11th hour plus duration is 6 hours. So total 17th hour. So 17 is the out time for next job. Okay. Look at the next job, that is job 9, and its out time from mission A is 13th hour. Okay. So here the previous job completion time on mission B is 17. 17 greater than mission A's current job out time 13. Okay. So mission B can take up the next job after completing the previous job only, right? Okay. So we need to enter greater value, that is 17 as in time for current job on mission B. Okay. So 17 plus duration 7 is equal to 24. So 24 is the out time. In the same way, for the next job here, 24 is greater than 19. So the in time for the next job is 24 on mission B. So 24 plus 6 is equal to 30. 30 is the out time. Okay. And the next one, 30, and the next job is 29. No, this is the greater value. So 30 is the in time for the next job. 30 plus 12, 42. Okay. Now for the next job here, 42 is lesser than 44. That is, mission B has completed the previous job on 42nd hour. Okay. But the current job, that is job 4 out time on mission A is 44. Now mission B has to wait for 2 hours to take up the next job. Okay. So we need to put greater value as in time for the current job on mission B. Okay. So 44 is the in time. So 44 plus duration 10. So totally 54 is the out time. Okay. In the same way, just look at the next job here. 54 is lesser than 56. Okay. So again mission B has to wait for 2 hours to take up the next job. Okay. So we need to put greater value as in time for current job on mission B. So now 56 is the in time, okay, on mission B. So 56 plus duration 10, 66 is the out time. Okay. Now in the same way for the next one here, 66 is greater than 65. So we have to enter only greater value. So enter 66 as in time plus 3 hours duration, total 69 is the out time. So in the same way for the next job, again we have to see the higher value. So here the out time is 69, but for the next one is 76 is greater value. Okay. So enter 76 as in time for next job. So 76 plus 1, 77 is the out time. Okay. So now we have completed in time and out time for mission A and mission B for all the jobs. Okay. Look at the problem. Determine a sequence of these jobs that will minimize the total elapsed time. Also find idle time for mission A and mission B. Now let us see the calculation for finding out total elapsed time and idle time for mission A and mission B. See the solution. The total minimum elapsed time means the total time taken to complete all the jobs, okay, through mission A and mission B, including idle time. That is, all the process will comes to an end at 77th hour. So this is the minimum total elapsed time, that is 77 hours. See, the total elapsed time is 77 hours. Okay. Now we are going to find out idle time for mission A and idle time for mission B. Now see the solution. See the solution to find out the idle time for mission A. Okay. For A, compare the last job's out time on mission A and on mission B. Okay. The difference is called idle time on mission A, that is 77 and 76. What is the difference? 1. That 1 hour is the idle time for mission A. See, idle time for mission A is 1 hour, that is 77 hour minus 76 hour. The difference is 1 hour. So this is the idle time for machine A. Now let us see how to find out idle time for machine B. See the solution. See the solution to find out the idle time for machine B. Okay. Look at the first job here. Machine B starts its process only in the 3rd hour. So till such time machine B is in idle state. Okay, that is the idle time. So write 3. This is the idle time. Okay. Now for the next job, we need to compare in time of current job and out time of previous job. Okay, on machine B. If there is any difference, that is the idle time. I will show how to find out idle time. For the next job, in time is 11, out time for the previous job is 11. So no difference. So no idle time. Next one, 17, 17, no difference. Then 24, 24, no difference. 30, 30, no difference. Then 44, 42, so there is a difference. Okay, so 2 hours is the idle time. Then 56, 54, so 2 hours idle time. Then 66, 66, no difference. Then 76 and 69, so what is the difference? 7 hours difference. So this is the way to find out the idle time for machine B for each and every process. Now find out the total idle time. 3 plus 2 plus 2 plus 7, 14 hours. The idle time for machine B is 14 hours. Okay. So far we have seen how to find optimal sequence for 9 different jobs and finding total elapsed time and idle time for machine A and idle time for machine B for processing n jobs through 2 machines. Okay. In the next video we are going to see processing n jobs through 3 machines. Okay. You can find the links in the description box. Hope you like this video. Please hit the like, comment, subscribe and share with your friends. Thank you.